So far, we have seen uh, complete details regarding the t-test. Now we will see what all types of t-tests we have for us. That's what we'll be seeing here. So various types of t-tests and their t-statistic t-statistic formulas. Okay. So the first one is independent sample t-test. So this test is used to compare the means of two independent groups. It determines if there is a statistically significant difference between the means of the two groups. So if we take an example, so this test can be used to execute different tasks. Out of that, the first one is this test compares the means of two independent groups if the variables of interest are continuous. Okay, and you can compare the means of the two groups if the variables are categorical, mainly binary. Okay, it's not exactly but mainly binary. And the third task that we can do with independent sample t-test was you can compare the proportions or percentages of the categories between the two groups. So this is how it's comparison between two independent groups. Next we have was paired sample test. So paired sample test, also known as a dependent sample t-test. This test is used to compare the means of two related or paired groups. It determines if there is a statistically significant difference between the means of the paired observations. So the best examples, the tasks that it's gonna execute under paired sample t-test was this test compares the means of two related or paired groups if variables are continuous. You can compare the means if the variables are categorical and mainly it's binary, and you can compare the proportions or percentages within each paired observation. And the third one that we have here is one sample test, one sample t-test. So one sample t-test, this test is used to compare the mean of a single sample to a known or hypothesized population mean. So it determines if the mean of the sample is significantly different from the population mean. And example tasks are this test compares the mean of a single sample to a known or hypothesized population mean if the variable is continuous, and same thing applicable categorical and binary. And you can compare the proportion, very important. So two tasks we can do majorly. One is mean based task, and then proportion. You can compare the proportion or percentage of a specific category against the known or hypothesized mean. But these are with respect to the statistician interest, statistics interest. And how about data scientist? With respect to data scientist, the independent sample t-test is very important. Which test is important? The independent sample t-test is very important. So with respect to data science, when determining the statistical significance of the relationship between two variables, the most commonly used technique out of these three was is that independent sample t-test. The independent sample t-test allows us to compare the means of two independent groups and assess whether there is a statistically significant difference between them. So this is often used to evaluate the relationship between a categorical variable and a continuous variable, or to compare the means of two different groups in a dataset. Basically, so this independent sample t-test is going to be vital tool for a data scientist to understand the statistical significance relation of uh, a dependent variable which is continuous and an independent variable which is categorical, maybe max to max two groups. Yeah. So in that case, binary. So in that case, independent sample t-test can be used to find out the statistical significance of the relationship between these two variables. Anyway, let's move ahead. Let's look into the each and every technique in detail, but we will be working on one example with respect to the independent sample t-test, because that's what at the end of the day we will be using that. So let's begin with one sample t-test. So one sample t-test is used when you want to compare the mean of a single sample to a known or hypothesized population mean. It helps determine if the mean of the sample is significantly different from the population mean. So now what are the assumptions under which it works? So the assumption number one is the data are normally distributed and the sample is a random sample from the population. And so now what's the procedure? How does this work? So procedure, it's similar to the z-test that we have seen. First formulate the null hypothesis H sub 0 and alternative hypothesis H sub A based on the research question. Then collect the data from the sample. Then calculate the sample mean and standard deviation. Then calculate the t-statistic, which compares the sample mean to the population mean, taking into account the sample size and the standard deviation. So this determine the degrees of freedom for the t distribution. So then compare the calculated t statistic with the critical value, with the critical t value from the t table, or use a statistical software to obtain the p value. If the p value is less than the predetermined significance level, which is 0.05, then reject the null hypothesis and conclude that there is a statistically significant difference between the same mean sample mean and then population mean. So this is how we calculate. If you do hypothesis test for one mean, if it is with respect to the mean, then the to calculate the t statistic or observed t statistic is equals to x minus mu divided by s divided by square root of 1. It's similar to z score. And if it is for the proportion, compare an observed proportion to a theoretical one, then we'll have p minus hypothesized proportion divided by square root of p naught minus p naught multiplied by 1 minus p naught divided by n. So p is observed proportion and p naught is hypothesized population proportion. Okay, so now let's take a few examples so that it would be pretty easy to understand. So example one, testing the effectiveness of a new teaching method. So this is what is the example. So research question is, does the new teaching method significantly improve student performance? So for this, null hypothesis is the mean test scores for students using the new teaching method are equal to a known population mean. So alternative hypothesis, the mean test scores of a students using the new teaching method are significantly different from a known population mean. So what we can do? So it's similar, exactly similar to the z-test. So data collection, collect test scores from a random sample of students who have been taught using the new method. Calculate the sample mean and the standard deviation of test scores. Then perform a one sample test comparing the sample mean to the population mean, taking into account the sample size and standard deviation and interpretation. If the p value is less than the predetermined significance level, conclude that the new teaching method has a statistically significant effect on the student performance. Then similarly, let's take one more example with respect to the proportion. So testing the accuracy of manufacturing process. So here, okay, this is also with respect to the mean. So research question is the average length of produced component significantly different from target length? So null hypothesis, the mean length of produced components is equal to the target length. So alternative hypothesis, the mean length of produced components is significantly different from the target length. So data collection, measure the lengths of a random sample of components produced using the manufacturing process. Then calculate the sample mean and the standard deviation of the component lengths. Perform a one sample t-test comparing the sample mean to the target length, taking into account the sample size and standard deviation. So interpretation, if the p-value is less than the predetermined significance level, conclude that the manufacturing process produces components with a statistically significant difference in length from the target. And this is what is one sample t-test. Now let's get into the paired sample t-test. Paired sample t-test. The paired sample t-test, also known as a dependent sample t-test, it's used when you have a paired observations, or when each data point in one group corresponds to a specific data point in the other group. It helps determine if there is a statistically significant difference between the means of the paired observations. So assumptions. Um First one, the difference between the paired observations are normally distributed. That's what the assumption. And the second assumption, the differences have a mean of 0. And the third assumption is the differences have a constant variance. So let's look into the procedure now. So formulate the null hypothesis and alternative hypothesis based on the research question. Collect the data from the paired observations. Then calculate the difference between the paired observations. Then calculate the mean and standard deviation of the differences. Then calculate the t-statistic, which compares the mean differences to 0, taking into account the sample size and the standard deviation of the differences. Then finally, determine the degrees of freedom for the t-distribution, and then compare the calculated t-statistic with the uh, compare the calculated t-statistic with the critical t-value from the t-table, or simply use a statistical software to obtain the p-value. So final step, if the p-value is less than the predetermined significance level, let's take 0.05, reject the null hypothesis and conclude that there is a statistically significant difference between the means of the paired observations. So for mean, the paired sample t-test compares the mean difference between paired observations to 0. So let's take let's see how this calculations to be done, because it's a paired sample t-test and it's a dependent t-test. The way we do the calculation is slightly differs with the other tests. So for mean, the paired sample t-test compares the mean difference between the paired observations to 0. So first we have to calculate the mean difference d bar between the paired observations. So d bar is equal to sigma summation of d divided by n. Okay, that's the average differences between the paired observations. So then where sigma d represents the sum of the differences and n is the number of pairs, then calculate the standard deviation of the differences, and after that we'll calculate the t statistic using d bar. D bar is our observed value, and then hypothesized mean difference is 0, and it's standard deviation divided by square root of n. That's it, and this is how we calculate t statistic. And here degrees of freedom is nothing but n minus 1. So we use the t statistic and degrees of freedom to obtain the p-value from a t-distribution table, or using a statistical software. So example, suppose we want to compare the effectiveness of two different weight loss programs, you randomly select 30 patients and assign each participant to one of the two programs. After a period of 12 weeks, you measure the weight loss for each participant. To determine if there is a significant difference in weight loss between two programs, you can use an independent sample t-test. So here the null hypothesis, the mean weight loss for participants in program A is equal to the mean weight loss for participants in program B. So alternative hypothesis, the mean weight loss for participants in program A is different from the mean weight loss for participants in program B. So you collect the weight loss data for each participant and perform an independent sample t-test to compare the means of the weight loss between the two groups. And we have another task to be done, can be done with paired sample t-test, which is proportion. For proportion, the paired sample t-test can also be used to compare the proportions by transforming the proportions into a standard normal distribution. So calculate the proportion of success p1 and non-success, it's 1 minus p1, it's a q1 for the first paired observations. Then p1 equals to x1 by n, q1 equals to 1 minus p1, obviously. So where x1 is the number of successes and n is the sample size. So calculate the proportion of success p2 and non-success q2 for the second paired observation. Calculate the pooled proportion of people. It's like p underscore pool is equals to x1 plus x2 divided by n plus n, if you have those many. So now where x2 is the number of successes in the second observation, calculate the then finally we have to calculate the standard error. So now calculate the t statistic using p1 minus p2 divided by standard error. So then we have to determine the degrees of freedom. Df is equals to n minus 1. So use the t statistic and degrees of freedom to obtain the p-value from a t distribution table or using a statistical software, and finally you can compare the level of significance with respect to the observed t statistic to determine whether it is significant or not. So a small example, a proportion example. So suppose you are conducting a survey to determine the proportion of customers who are satisfied with a particular product. You collect responses from a random sample of 200 customers to determine if the proportion of satisfied customers is significantly different from a hypothesized value. Example is 0.5 representing equal satisfaction and dissatisfaction. So we can use for that we can use a one sample proportion test. Here it's not basically paired sample t-test, whatever example that we have mentioned, but I just want to give one example with respect to the proportion. So that's the reason I have mentioned a proportion example which is connected to the one sample t-test. Okay, but see, this is mostly connected with that one sample t-test or dependent or paired sample t-test. These are very heavily connected with statisticians, whereas for us the point of interest or the entity of interest for us is independent sample t-test. Okay, so independent sample t-test is very important for us, so that's what we'll be looking into now. So now let's look into the entity of interest for a data scientist, which is uh, independent sample t-test. The independent sample t-test is used when you want to compare the means of two independent groups. It helps determine if there is a statistically significant difference between the means of the two groups. The test compares the means of the two groups and assesses whether the observed difference is likely due to chance or represents a true difference. So let's see some of the assumptions here first. So the data in each group are normally distributed and the variances of the two groups are approximately equal, and the observations in each group are independent of each other. So now let's see quickly a procedure. So formulate the null hypothesis and alternative hypothesis based on the research question, then collect the data from the two independent groups, calculate the t statistic with the critical t value from the t table, or use a statistical software to obtain the p value. If the p value is less than the predetermined significance level, reject the null hypothesis and conclude that there is a statistically significant difference between the means of the two groups. Okay, so how do we calculate the t statistic, observed t statistic? That's using this formula. So a hypothesis test for difference means, if it is with respect to the means, this is how we calculate. So we will take up two groups, and two groups will have a separate means, x1 bar and x2 bar. These are the means of the groups, and mu1 and mu2, the difference of x1 minus x2 bar, x1 bar minus x2 bar, that's the difference of the mean of the groups, and mu1 minus mu2 is the difference of the hypothesized mean of the groups, and divided by s1 s2 are the standard deviations of the groups, and then n1 is the sample size of the groups. Of course, we will have closer, we do not know exactly what's the sample size of n1 and what is the sample size of n2. Okay, so then we can do the same with respect to the proportions, but hypothesis test for a difference in proportions. So here p1 p2, these are the proportions of the two. This p1 is p1 minus p2, that's what the proportion of proportion difference of the two groups, and p and 1 minus p. So this is the percentage of success and percentage of failure. We can say it as p and q, and n1 n2, anyway it's sample size of the n group 1 and group 2. So let's take this example. So now, as it is a data science example, now we'll be taking up a data science example. So example of selecting features using the t-test for statistical significance. Okay, that's what we want to select a feature using t-test for that to specifically independent sample t-test for statistical significance. Okay, let's work on this example. Okay, so the example here that we have is to get the, let me start. Okay, let's say we are working on a project to predict a customer churn. So what's the example for us that we are using? It's basically a real world example. So most of the data scientists uh, would have faced this challenge of working on this project. So let's say you are working on a project to predict customer churn for a telecom company. You have a data set that contains various customer attributes such as uh, age, gender, monthly charges, tenure, and whether or not the customer churned. Now, so how to handle this problem? So identify to identify the features that are statistically significant in predicting churn, you can use the t-test. The t-test will help you determine if there is a significant difference in a particular feature between the churned and non-churned customers. For example, you can perform a t-test on the monthly charges feature. The null hypothesis would be that there is no difference in the mean monthly charges between the churned and non-churned customers. On the other hand, the alternative hypothesis would be that there is a significant difference, and that's how we formulate null and alternative hypothesis for selecting features. Okay, now let's do it step by step.